Hello everyone, I hope you all are doing well. This side Priya Bhatia. And in this specific video, we are starting our third type of ensemble technique. See, till so far, whatever things we have covered up in the ensemble technique part is about the bagging technique and the stacking technique, right? We have seen a lot in-depth implementation plus logical intuition behind the same. Now, today, you can say from this video onwards, there will be three sections which I would say you will find in this particular course, where I'll be talking about the boosting techniques only. But specifically, there are three major, very famous techniques that we have, which is ADA boost, gradient boosting, and XG boost. All of them we will cover up in a separate module, where first of all I will talk about the in-depth intuition behind the same, followed by the logical, you can say, implementation, right? Just like the way we have done all the course. Please make sure that you will try to focus on whatever things I am conveying here. Again, very interesting technique, very widely used in a lot many industry projects, right? So please make sure that you will be able to understand the internal intuition in depth, right? So without wasting any time, let's get started. So whenever we are talking about boosting algorithms, you will be able to observe that the one common thing between bagging and this specific algorithm is that both of them are using, I would say, homogeneous models. I hope everyone knows the literal meaning of homogeneous. Homogeneous means similar models. If you remember, in the bagging technique also, I told you that you cannot use different algorithms. For example, in stacking, we are using that, right? That is the common part. But how these two techniques are different, let's try to understand in a more depth. Boosting relies on the concept where it says that I will try to combine multiple models, weak learners, and curate a strong learner out of them. I think that nothing is clear from this particular line. So let's try to see with a real-time example, and then I think the intuition behind this boosting algorithm will be pretty much clear to everyone. For example, I'm, let's say, teaching in one of the, you can say, guest lecture, and let's suppose I'm saying that I'm giving 5 questions to the students. Okay? So the set of questions are 1, 2, 3, 4, and 5. Now, let's suppose I'm giving, let's say there are 5 students in my class, and I'm giving first of all the problems, all the 5 problems to the student 1. Okay? Let's say here is a student 1, S1, and I'm giving all these 5 problems to S1 only. Now, let's consider a situation where S1 will be able to give me the correct result for the problem 1 and 2. But he is somehow doing a wrong thing, or he is providing me a wrong output or a wrong result of the problem number 3, 4, and 5. So what I'm saying, I'm repeating it again. S1 is the student of mine, and I have given him 5 questions to solve. Let's say that 2 questions he has solved it correctly. So this is something which he has solved it very much aptly. But these are the wrong ways he opted to solve this approach, to solve this problem. So what I will do is, I will now call student S2. I will call student S2 and will say the same problem, but here I will focus and give the problem which is wrongly given by the student S1. So what I'm saying to student S2, I'm saying that in S2, take the problem number 3, 4, and 5 and give me the correct result. Now, let's say S2 is also not that much smart enough, but he's not that much dumb also. So what he has done is, he has tried to give me the correct answer of 3, but still he has given me the wrong answer of 4 and 5 question. So again, on the left hand side, I am just writing the correct results given by the students, and on the right side, I am writing the correct wrong results. On the left side, I am writing a right result. So let's say on the right side, they are giving me a wrong result. Now what will happen? I will say that, okay, now till so far, I just have the corrections or correct results of 1, 2, and 3 question. Still 4 and 5 is pending. So maybe I will be having some other student S3. Now I will call him and I will say that, can you solve the problem number 4 and 5? But again, I'm just giving now the problem number 4 and 5 for the student S3 and not the problem number 1, 2, 3. Now student S3 is smart but not that much smart, so he has solved the problem number 4 correctly, but 5 also he has done somewhere wrong. This is correct. Now what will happen? I will again call maybe the student S4, and in the student S4 I will provide only the next problem just as problem number 5, and let's say he will be able to give me the correct result of that problem number 5. So at the end of the day, I will be having a correct solution of all the problems from 1 to 5 given by me, right? So, but here you will be able to observe only single S1 or only single S2 or only single S3 is not able to provide me a correct result. If I will try to combine all the results from S1 to S4, then only I can say that I will be able to get the correct result. Then only I can say that I will be able to get the output of all the 5 questions that I have asked. This is the core idea, I would say. This is the core idea behind the boosting algorithm. That is where this word boost came into picture, right? So here what we are doing is we are trying to combine the results of the models now. So here replace the complete analogy with the models. Let's say here we will be having M1 model. Here we will be having M2 model. Here we will be having M3 model. Here we will be having M4 model. So what is happening in this scenario that we will be having same models only, and let's say this is decision trees that we have, and at every point of time few of the results are correct, few of them are wrong. So the results which are wrong, that is something which we will pass the next model, and we will train again the model. We will get some great results, we will get some bad results. Again we will pass the bad results to the next model. This process we will keep on repeating until we reach to a point where we will be able to have all the correct predictions available with us. This is why it is called as boosting. And whenever you will refer any standard book, maybe you will refer hands-on with machine learning book, you will see that they are saying all the weak learners, when we are combining together, when they are combined together, what will happen is they will be able to form a strong learner. And with this, we will be able to improvise the accuracy. With this, we will be able to, I can say, improves the overall results of the model. So this is the core idea, you can say, behind this boosting algorithm that we have, right? One thing which you will be able to observe here, although we will discuss in the upcoming section of the video, the difference between bagging versus boosting versus stacking, because now we know the core idea behind all of these techniques. But still, I just want to highlight one point here, which I think that you must have observed with respect to whatever core idea I have provided you here. One thing, if you will be able to observe, this is a sequential process. Can you observe this? We are first of all going from S1. S1 will get some results. We will evaluate that. We will see how many of them are correct, how many of them are wrong. Then we will call S2, then we will call S3, then we will call S4, and so on. So one thing which you will be able to observe, that this is a sequential learning, not the parallel thing which was happening in the bagging technique, right? So this is something is really, really important in the boosting algorithms part. Specifically, we have 3 important algorithms. One is called as AdaBoost, which is called as adaptive boosting algorithm, AdaBoost. Second algorithm that we have is gradient boosting, and the last one is called as XGBoost, right? So first of all, we will try to understand in our upcoming modules the complete core idea behind AdaBoost. Then followed by, we will have a module of gradient boosting. We will try to discuss the internal intuition behind that one. And finally, we will try to see the XGBoost. This is something which I would say is a most powerful algorithm, which is quite frequently used in a lot of industries, right? Even in the, you will be able to observe, initially when it was designed, it was very frequently used for the image-based task also. But now we have deep learning algorithms which will be able to get the complex information pretty well. But still, it is the most powerful algorithm to capture the information from the given data. And that is why it is really important to understand the internal intuition behind the same, followed by the implementation, that how can we implement them. One more thing is very important in these algorithms is hyperparameter tuning. So I will definitely try to showcase you in this course that how basically we can tune our hyperparameters Obviously, algorithmically, things will remain same that we have already covered up, which is grid search CV and randomized search CV. But the important thing which we have to discuss here is that what are the important parameters in this algorithm, in all of these three algorithms that we have, which we have to take care of. So this is the overall idea behind this course and this particular module that we will try to start now in the near future. So please make sure that you should be getting clear about the core idea of boosting algorithm before we will move ahead, right? So now I hope that you will be able to get a clear-cut picture of what is the internal meaning of, boosting technique. In the upcoming part of the video, you will see that we will be discussing about the difference between bagging versus boosting versus stacking. What's the internal difference between these three techniques that we have? Because now we are in a situation where we know the internal working of both of them. Although we have not covered up till so far the algorithm of boosting, but I feel that intuition wise it is clear from this video, right? So in the upcoming video, let's try to see the difference between these three, and then we will try to deep dive more into this boosting part, right? So bye bye everyone, and I'll see you all in the upcoming video.